some form of notes. We're just going to look at this investigation for a second. We have a wall that's to be constructed along the 1 kilometer boundary between a city park and a busy street. The wall will be built using cinder blocks measuring 20 centimeters in height, 40 centimeters in length. So something like this, where the height of this is 20 centimeters and the length of each block is 40 centimeters, okay? And it keeps going. Each row in the wall will contain 100 fewer blocks than the previous row. So if we could zoom out on this building and we'd see a row of blocks there, and then a row of blocks there, and then a row of blocks there, and then a row of blocks there. It's about what it would look like. Each row in the wall will contain 100 fewer blocks than the previous row, and the wall will be 3.6 meters in height at the center. So by the time you get enough rows from top to bottom, 20 centimeters into 3.6 meters, the wall will be 3.6 meters tall, okay? So what are we going to do? We're going to fill in this chart. I'm going to leave you to mostly do it on your own, but you have the row number 1, row number 2, row number 3, row number 4, row number 5, etc. However many rows it takes. And you're just going to list the number of blocks in the row. So the first row is given for you. It has 2,500 blocks. The next row is going to have 100 fewer blocks. So 2,400, 2,300, etc. Okay? Then we're going to look at the length of that row of the wall. Well, it's 2,500 times 0.4 meters, right? Or you could do it in centimeters, 2,500 times 40 centimeters, which gives us 100,000 centimeters. And then for the next one, if we are looking at 100 fewer blocks, and every block is 40 centimeters, then we are looking at 4,000 fewer centimeters, which brings us from 100,000 to 96,000. And that pattern will continue on down the way. Okay, so you can fill in that part of your chart at least up until the 5th row. And then you're going to write the number of blocks in the row as a sequence. You're going to graph it. You're going to write an explicit formula using the skills already developed earlier in this unit to represent the number of blocks in row n. Row n represents any row, right? An explicit formula that will get you the number of blocks for any row as long as you know the row number. Okay? Then number 4, what is the value of n for the top row of the wall? So you're going to figure out how many rows you need in order to get the height of the wall that you need. Use your explicit formula to determine how many bricks are in that wall, how many blocks are in that row. And then that's actually it. That's all you need to do. Once you've done that, go ahead and press play on the video. Just press pause now, and we'll carry on with some notes and lesson. At the top of your next page in your notebook, you have a little bit of space for notes. I'm going to give you a few general notes on the left, and then specific to this lesson, basically a definition for arithmetic sequences on the right. But something we need to know as we've been talking about sequences and as we move into series and all of these different patterns and formula that we have been writing, we've come across a lot of symbols and terms that we need to make sure we understand fully, okay? T sub n. This is essentially the y of the formula. We often get formulas or equations in y equals yada, 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 okay? So T of n is basically the value of the term that you're interested in, okay? So this is just the general term. Whenever you're looking for the value of a term or the term itself, which is the same as the value of the term, you're thinking T of n. I'm just looking for some term. Don't know which specific number. Sometimes I do, but that's just the terminology or the symbol for a term in the sequence. It's often used to name the last term of a sequence. Okay, and that's easy to see because we often name our terms, you know, t of n, and the one before that is t of n minus 1. The one before that is t sub n minus 2. This basically just means the term before, okay, or the preceding term. Then we have a, which is always the first term. In other formulas, a is the typical symbol for the initial value. In some sequences, like arithmetic sequences, which we're tackling today, you have d, which is the common difference. So in an arithmetic sequence, you get from term to term by adding or subtracting a constant. That constant is d. It's known as the common difference. Tomorrow, in lesson 6.5, we learn about geometric sequences. And in a geometric sequence, to get from term to term, we have a common, hopefully you can recall what R stands for typically in math when you're not doing geometry, because then it would be radius, but it's a common ratio. So to get from one term to the next, you are multiplying by a number or a value. It could be a fraction or a positive or negative, whatever. And then we have the letter n. This is the x. It's the independent variable. So if t sub n is the y, then n is the x. That's the term number. Okay, so there's a handful of things that you should already be fairly familiar with. You're going to need them going forward, okay? Now on the right side of that page, we will have two definitions, the first of which is arithmetic sequence. Arithmetic sequence. This is a sequence where the difference between consecutive terms, or the difference between consecutive terms is a constant. Okay, so you can test if a sequence is arithmetic simply by taking the first differences. And if you take the first differences and it's constant, then you know it's an arithmetic sequence. It means you got from term to term by adding or subtracting a constant value. Okay, constant, this is called the common difference. Okay, so we have arithmetic and now sequence, common difference. This is the difference between any two consecutive, terms in an arithmetic sequence. Okay, these definitions go hand in hand. If it's an arithmetic sequence, it'll have a common difference. The difference between consecutive terms will be constant. If it has a common difference, it's an arithmetic sequence. If it's not an arithmetic sequence, it won't have a common difference. If it doesn't have a common difference, it's not an arithmetic sequence. Okay, so we will dig into a few examples and see if we can discover what's going on here. One more note to squeeze in there at the bottom underneath your common difference note is an arithmetic sequence can be written, a plus d, a plus 2d, a plus 3d, dot, 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 okay? You have your first term, then you have the value of the first term plus or minus whatever the common difference is, okay, plus the common difference. Then for your next term, you're simply doing the common difference again, and then doing the common difference again, okay? Then the formula for the general term, so how to get any term in an arithmetic sequence, for the general or nth term is t sub n equals a, your initial value or your first term, plus, well, how many differences are we going to have? We're going to have one less difference than the term number, okay? A is term 1, it has no differences. This is term 2, you have d times 1. This is term 3, you have d times 2. This is term 4, you have d times 3. So no matter what the case, you're going to start with your first term, then you're going to add the number of common differences that is one less than the term number that you're interested in. And a little just where n belongs to the set of natural numbers, okay? Ordinal numbers that we count with, beginning at 1. 1, 2, 3, 4, 5, 6, on and on and on. Example 1, we are given arithmetic sequences, and we need to determine the values of the first term, a, and the common difference, d. The sequence we're given in A is -4, 0, 4, 8. Okay, it's arithmetic because I do the same thing to get from term 1 to term 2 to term 3 to term 4. And they already give us the first term. So the first term is given, it's right there. So A equals -4. Now to get the value of D, you can see it here, but to get the value of D, the common difference, we could put a little note here, find D by subtracting consecutive terms. So we're going to take term number 2 and we're going to subtract term number 1, okay? It's important to always subtract backwards, yeah? Just like when you're finding the first difference of something, it's y2 minus y1, then y3 minus y2. Same thing here, term 2 minus term 1, and if we wanted to check our answer, we could do term 3 minus term 2. For now, we'll just sub in what we know. Term 2 is 0. Term 1 is -4. And that's going to give me a difference of 4. All right? So again, you could check this, double check this, by taking term 3 and subtracting term 2. And you would get a difference of 4. Okay? Now to do it multiple times also confirms that it's an arithmetic sequence. But there we go. We have an initial term of -4 and a difference, common difference of 4. In the second example, we have the sequence 1/3, 5/6, 4/3, 11/6, and carrying on. Now this one, at first glance, might not look like an arithmetic sequence at all. I know it is because I can see the example. But all we have to do is follow the same steps. A is given. It's 1/3. And to find D, we simply take term 2, subtract term 1. So we get 5/6 minus 1/3. In order to subtract fractions, I need a common denominator. So I've got 5/6 minus 2/6, which gives me 3/6, which gives me 1/2. Okay, so D is 1/2. And again, you could pick any two consecutive terms. You could have done 11/6 minus 4/3, and you'd get D equals 1/2. In C, we're not given the terms of the sequence, we're given the explicit formula for any term in the sequence. So what we're going to do is we're going to use that explicit formula to find the value of the first term. So wherever I see an n, I sub in 1. So I get 2 times 1 is 2, plus 3 is 5. Then we're going to find the second term. Sub in 2 wherever we see n. We get 4 plus 3 is 7. And we're going to find the third term. Sub in 3. 6 plus 3 equals 9. So now I have the first 3 terms of the sequence, 5, 7, 9. All right, so A is 5. And from 5 to 7 is 2. 7 to 9 is 2. Just by observation, we can determine that the value of D is 2. Okay, so that time we weren't given terms in the sequence. We had to get the terms of the sequence first and then apply the same reasoning that we did in A and B. Example 2, we're asked to determine the formula given the sequence. So we're going to consider the sequence -13, -19, -25, ... And A asks us to figure out if it is arithmetic or not. Okay, so by observing the terms, we've got a first term of -13, and to get from -13 to -19, we're decreasing by 6. To get from -19 to -25, we're decreasing by 6 again. As soon as I determine that there's a constant difference, I can confirm that this is indeed arithmetic. Yes, arithmetic consecutive. How do we know this is true? Well, consecutive terms decrease by a constant, in this case, comma 6. So that's how we know it's arithmetic. Term to term, it decreases by a constant. There is a common difference. B, develop an explicit formula for the general term. Well, let's write down what we know. We know A is -13, and we know that D is -6. And we know that a formula, a general formula, is T sub n equals A, our first term, plus n minus 1 D. Okay? Here we go. Sub in what we know. A is -13. N minus 1. We don't know how many terms there are, but we know D is -6. Okay, so we take this formula. I'm going to now just expand this and reduce. So we've got -13 plus -6 times n, so -6n, and then -1 times -6 is +6. I reduce this, I end up with -6n minus 7. Okay, there is a formula for the general term. Or we could use function notation. We could say f with respect to n is equal to -6n minus 7. C, write the value of the 15th term. We'll do one more going down. So the value of the 15th term looks like this, right? The 15th term. Take my formula, sub in 15. -6 times 15 is -90, minus 7, -97. All right. I am moving over to the right to do D. D says determine a recursion formula for the sequence. So remember, a recursion formula is how to get from the preceding term to the next term, okay? So because an arithmetic, I'll say since an arithmetic sequence can be written as a, comma, a plus d, comma, a plus 2d, comma, a plus 3d, etc. Then we just need to take our term numbers, and just like we did in previous lessons, we will figure out what they are. So we've got term 1 is a, term 2 is a plus d, term 3 is, I'm just going to back up, term 2 can also be written as term 1 plus term d, which is why we can write it as a plus d, because a is term 1. Term 3 is term 2 plus another common difference. And all the way down the list, you notice what's happening here. For term 2, you're taking term 1 plus d. For term 3, you're taking term 2 plus d. For term n, you need to take the preceding term, term sub n minus 1, plus d. And since we know the first term of our sequence is negative 13, and we know that the value of d is negative 6, we can simply fill this in. Here's our recursion formula. Recursion formula. Okay, 2 parts. Has the first term and how to get to the next term. Example 3, applying this. Anna paid $5,000 for an antique guitar. The guitar appreciates, goes up in value, by $160 every year. If she sells the guitar for a little over $7,000, how long has she owned it? All right, some things that we know. The value of the guitar increases by a constant amount every year. So it is an arithmetic sequence. What is the first term in the sequence? It's going to be the value of the guitar after 1 full year. Okay, so she pays $5,000, but we should make a note. The first, that would be like term 0 if there were such a thing, okay? The first term is the value of the guitar after 1 year of ownership. Okay, so in the first year, it has a value of $5,000. In the second year, which is after 1 year of ownership, it will have a value of $5,160. Okay, the first term is the value of the guitar after 1 year of ownership, which is $5,160. So we know the value of A, $5,160. We know the value of D, it's increasing by $160 per year. And in this case, we know the last term of the sequence, or the value of the guitar that we are interested in after n years, $7,000. But we don't know what n is. What we're going to do is we're going to take this information and sub into our general equation, which is T sub n equals A plus n minus 1 D. And you should go ahead and, if you haven't already, go ahead and memorize this general formula. Okay, it's going to be the arithmetic sequence formula. You're going to get a new one tomorrow for geometric sequences. So commit that to memory so that you can use it. All right, the term that we're interested, T sub n, is 7,000. it equals A, which is 5160, plus n minus 1, we don't know what n is, times D. So we're going to get $160 increase every time period, every year, but we don't know how many years it's going to take. So now we're simply solving. I'm going to go ahead and simplify this side by expanding. So I have 7,000 equals 5160 plus 160n minus 160 gives me 7,000 is equal to 5160 minus 160 is 5,000 plus 160n. Subtract 5,000 from both sides. Divide both sides by 160. N is equal to 12.5. So if Anna was able to sell it for $7,000, then Anna owned the guitar for 12.5 years. Okay? Use the information that you know, plug it into the formula carefully, and interpret the results. In example 4, we have to determine A and D. We've been given nothing about the sequence or the formula except for 2 of its terms. Okay, so I just quick jot down the given information is that the 11th term is 72 and the 21st term is 142. Now, this is kind of like a question where you have to develop the equation of a line, and you don't have the slope and you don't have the y-intercept, right? You don't have the slope and you don't have the y-intercept, but you do have 2 points on the line, okay? So if you can do that, you can do this. Here we go. I'm going to substitute the values that we do know, which is simply the idea that if n is 11, t of n is 72, and if n is 21, t of n is 142. So we can actually develop 2 equations using our general equation to develop a system of equations. And I hope that language is familiar. Okay, so for t sub 11 equals 72, we take our general equation, and maybe I'll write our general equation up here somewhere. T sub n is equal to a plus n minus 1 d. So I'm going to take that equation and I'm going to sub in n is 11 and the value of the term is 72. So we've got 72 plus n minus 1. So that's going to be, 72 equals. 72 equals a, because we don't know a. N minus 1 becomes 10, because it's 11 minus 1. So 72 is equal to a plus 10d. Okay. Our second equation for this system comes from the 21st term. And it is 142 equals a plus, well, 20 minus 1 is 20, 20d. Now we have 2 equations, 2 variables. I'm going to go ahead and number my equations. And I'm going to use either substitution or elimination. I'm going to use elimination here. And I notice I can eliminate my a term if I take equation 1 and subtract equation 2. All right, so let's do that to all the terms. We've got 72 minus 142 leaves us with negative 70. A minus a is 0. 10 d's minus 20 d's is negative 10 d, divide both sides by -10, d equals 7. So the common difference is 7. Now to find out what a is, sub d equals 7 into, and I can use equation 1 or equation 2. 1 seems easier. So what do we have? 72 equals a plus 10 times 7. 72 equals a plus 70. A equals, subtract 70 from both sides, a equals 2. Therefore, the first term is 2, and the common difference is 7. There you have it. Okay, quick review. An arithmetic sequence is a sequence in which the differences between consecutive terms is constant. The difference between consecutive terms is called the common difference. And the formula up here is how we find any term using the value of the first term and the term number that you're looking for and the common difference, okay? And you can use different pieces of the equation to find the other pieces. So whenever you're missing one piece, either n, a, or d, or t of n, you can find that one missing piece if you have the other pieces. And if you're missing two of the pieces, well, that's no problem. As long as you know a couple of the terms in the sequence and where they lie in the sequence, you can create two equations, two variables, use elimination, find those missing values. All right, your practice problems are on page 385. Page 385, numbers 1 through 18.